Pre-Algebra, Mr. Lawrence here with your flipped lesson for Monday, February 27th. And today we're going to be talking about volume and surface area of pyramids and cones. First, I want to point out that, pyramids are not just what you see in Egypt, right? Your traditional pyramid you guys are used to seeing kind of looks like this, right? And then that kind of goes back that way a little bit, and that kind of comes down. And if I do it 3D, which I'm not super stupendous at, but I will do my best, it's going to kind of go like that, and then like that, and then like that, right? And it's a pyramid with a square base. But a pyramid doesn't have to just have a square base. A pyramid could have an octagonal base. And I'm going to try to off-center that a little bit so that my lines don't look too confusing. And then I could kind of go like that. See, that's a hexagonal pyramid. It's a pyramid with a hexagonal base. All right, these lines you wouldn't be able to see. And of course, these back lines here too should be broken, but I'd already drawn them that way. All right, so the techniques we're going to use work for all pyramids, okay? Triangular base pyramids, pentagonal base pyramids, whatever the case may be. All right, so let's get ourselves a nice looking pyramid out here. Hold on one second. Okay, there's a pretty good looking pyramid, and we're going to tell you that it is a square base. It doesn't quite look like a square because of the angle we're looking at, but we're going to go ahead and let it be a square. And so I'm going to mark it as a square, and I'm going to say that this is going to be 10 centimeters on the base. Okay, now to be able to do the surface area, we are going to need this information. We're going, oh, I'm sorry, that's going to be for the volume. Excuse me. Let me get rid of that. I'm going to need that later, but right now I'm going to need this information. I don't know if you can tell what I did. I took the triangle, which kind of looks like this, and I drew in the height of the triangle, right? Okay, I need to know how long that is. That's the face there on the right of the pyramid. And I'm going to tell you that that is going to be 12 centimeters. Okay. Now, that is not the actual height of the pyramid. That's the height of the face. You understand? That is at a slant. If I want to measure how tall the pyramid is, I want to measure from the very top down to the very bottom. Okay, which would be a number less than 12, I do believe. Yeah, hold on one second and I can tell you. Yeah, the total height would be about 10.9 centimeters, and that is rounded to the nearest tenth. If you're wondering how I did that, I used a little Pythagorean theorem. I saw this right triangle here, see, where this blue segment is the side I just found. So, like that. I knew that was 12. I know this is 5 because it's half the way across the square. And then this would be x, and I did x squared plus 5 squared equals 12 squared, and I solved for x. X squared plus 25 equals 144. X squared would equal minus 25. Well, minus 24 would be 20, so this must be 119. And then I took the square root of each side, so x would equal approximately 10.9 centimeters, all right? But again, we don't need that for surface area. So for surface area, I'm going to draw my flat network, first of all. And my flat network, I know I'm going to have a square base, right? And then the petals of the flower open up. And I have a triangle off of each side of that square base. Now I know these triangles are congruent, so the only information I need to put in would be this, which was what, 12 centimeters. And remember, the base of the triangle is 10 centimeters, and this is a square, so all 4 of these are congruent. So if I do the area of the square, I'm going to do 10 times 10. 10 centimeters times 10 centimeters, which is 100 centimeters squared. Okay, if I do the area of the triangle, I'm going to do the base times the height, but I'm going to cut it in half. Well, the base is 10 and the height is, the triangle is 12, and I'm going to divide by 2, and that's going to end up being 60 centimeters squared. Now I know there's 4 of these, so I can either list 60 down 4 times, or I can multiply 60 by 4. This is one good way to do it, and then I can't forget my square. And these are all centimeters squared. 0, that's 4, carry the 2, 340 centimeters squared. That is the surface area of my pyramid. All right, so let me see here. Now we need to worry about the volume. Well, the volume, I'm going to need the area of the base. I'm going to multiply the height, but I'm actually going to divide by 3, and you're going to find out why in class tomorrow, okay? Volume of the base, excuse me, area of the base times the height, and then I'm going to divide the whole thing by 3. So this is the area of the base. And this is the height of the pyramid, not the height of one of the sides. All right, height of the pyramid. Okay, so I know the base is a square. I know the area of the square was 100. How do I know that? Because I did it before. 10 centimeters times 10 centimeters equals 100 centimeters squared, right? Now the height of the pyramid, I used the Pythagorean theorem to figure out. The height of the pyramid is this number here. So that's 10.9 centimeters. So I'm going to take 100 centimeters squared, and I'm going to multiply it by 10 and 9/10 centimeters squared. But then I'm going to divide the whole answer. Oh, no, not centimeters squared, just centimeters. Sorry about that. But I'm going to divide the whole thing by 3. So this will give me the volume of my pyramid. Okay. Well, this numerator is a pretty easy multiplication. It looks like 1, 2, I'm going to get 1090 centimeters cubed, but I need to divide by 3. Now I know that's not going to go in evenly, because if I add up these digits 109 and 0, I don't get a multiple of 3. I don't get 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So I could go to my calculator, but I'm feeling intellectually vibrant today, so I'm going to do a little long division. 19 is going to be 6, 18, it's going to be a 10, and, oh, that's okay. That's going to go in 3 more times, and I'm going to get a 9, and then watch what's going to happen. We're going to have a decimal point, but I'm going to get 10 every single time. See, I'm going to get 9, subtract, 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 and then 10 again, and then 10 again, and then 10 again, and so that's going to be that. So the volume of this pyramid is going to be 363.3 repeating, or 1/3 centimeters cubed. And again, in class tomorrow, we will explore how to do that. Now, as far as cones go, for cones, it's almost the same thing. I'm going to start with the volume. So the volume of a cone, you're going to do the area of the base, which in a cone is a circle, times the height of the cone, and divide by 3. Okay? So if I draw a nice pretty cone here, something like that, and go whoop, there we go. And I tell you that the radius of this is, I don't know, let's say 8 inches. Okay? And I tell you how tall this cone is. All right? Let me see. Let me make that, I don't know, 12 inches. Okay. Yeah, there we go. Now I can do the volume. So I need the area of the circle, which is my base, which I use pi r squared. So 3.14 times the radius squared, which is the same as 3.14, 3 and 1400ths, times 64. Hold on one second. This comes out to be 296 hundredths centimeters squared. That's the area of the circle, right? Well, now I have to multiply that number by the height, so do the volume. Remember, it's area of the base times the height, and then I'll divide by 3. Area of the base is going to be this number that I just figured out. The height of the pyramid is 12, and then I'm going to divide by 3. Now, those of you that have been paying attention to me, you know you can do this. You don't have to do that, but you certainly can. All right, it will work out the same. I'm going to get 803 and 84 hundredths. So I think I'm in inches. I said centimeters there. Sorry about that. So it's going to be inches. Up here it'll be inches squared, and this will be inches cubed. All right. Now, again, if you don't know what I just did there with the 3 into the 12, you can just multiply the 296 hundredths by 12 and then divide the answer by 3. I'm telling you I simplified my fraction first. All right, to do the surface area, we need the formula because there is no simple way to do this. Hold on one second. In the surface area of a cone, this is for cones. Oh no, I'm having computer trouble of cones. That's cool how we're changing color. All right, the surface area of a cone is pi r squared, that would be the area of the circle, plus pi r l. All you need to know is what's L. L is the slant height. The slant height. So in a cone, okay, this side here, this is the height of the pyramid, right? The slant height is this. This is your slant height. It's if you measure how tall the cone is along the slant. You would never do that for a person. You always measure their height vertically. Okay, but to figure out the surface area of a cone, you need the slant height. It might have something to do with the flat network of a cone looking something like this. Okay, that's just a rough estimate. Actually, I think the circle belongs on the other side. Silly me. Let me move that circle to the other side. Okay, the surface area looks something like that. Excuse me, the flat network. Okay, so let's go back up and get our numbers of our cone. Let's see here. We know that this radius here, this guy, is 8 inches. Okay, we know that this is 12 inches, but we don't know L. We don't know L. Well, do you see the right triangle right there? L would be the hypotenuse, so I'm going to go 8 squared plus 12 squared, and I'm going to make it equal to L squared. And that'll be 64 plus 144. Ooh, that's gross. And that'll be L squared. Oh, and that's going to be an 8, a 0, a 208, L squared. I will take the square root of each side. Give me 1 second to do that. Let's see here. And it looks like the slant height ends up being 14.4 inches. And that's rounded to the nearest tenth again. It doesn't come out perfect. All right, so to find the surface area, I'm going to do pi r squared, pi rl, pi r squared, pi rl, pi r squared plus pi rl, pi r squared plus pi rl. So 3.14 times 8 squared plus 3.14 times 8 times 14.4. Now our answer will be off slightly, not that you'll be able to tell, but because I'm using 14.4, which is not the exact answer, but a rounded answer. But I'm just punching in a calculator, and you guys are so lucky because the calculators today let you punch the whole display in so you can see what you typed. And so the surface area of this cone will be 562 and 69 hundredths inches square. All right, and it came out to be 0.688, and I rounded it to the nearest hundredth. All right, there you go, pre-algebra. I think you'll really like tomorrow's lesson. Make sure you're watching the video, staying up. We'll probably be having a quiz pretty soon. Mr. Lawrence signing off.